computer is a fairly unique machine in that it consists of a fixed hardware platform, but it can carry out pretty much an infinite number of different tasks. Now, even though the hardware's fixed, it can do this because it can run different types of software. So games, web browsers, media players, word processors, and then in the case of embedded systems, we've got a custom embedded firmware. So the fact that it can run different software means that it can do different tasks, and the software consists of different instructions that are stored within the computer memory, and then we can change the instructions that are stored in the memory by loading in different software. So this idea is called the stored program concept. So a stored program computer is simply a machine in which we can store in different instructions which will change the functionality of that fixed hardware platform. So when it comes to executing these instructions, the computer just simply fetches an instruction from memory, executes it, then it'll fetch another instruction and so on. So look at the components that make up a stored program computer. We've got a processor. Now this is the thing that actually executes the instructions. Then we've also got memory. So the memory, the instructions live in the memory, and then any data that is needed will also be in that memory. So an instruction, there might be an instruction to add two numbers together. So the add instruction will be stored in this part of memory. That's it, add. And then the data, so maybe the first value, if you want to do 5 plus 7, for example, the kind of values, the data will be in the data memory, which is often the RAM. And instructions can be the ROM or the flash. And then when this instruction gets executed, the result will again written to RAM. And then we also need buses as well. So the buses are used to shift data back and forth between the processor and the memory. So the processor might need to read data when instructions into the processor, and when it's executed it and it's got the result, I need to write it back. So this is a kind of two-way bus. And then we also got an address as well, so that the memory is partitioned into different slots, as we've seen before. So by selecting a particular slot, we do so by supplying the address on the address bus. So look at the fetch execute cycle. So this is essentially what it boils down to. The computer simply executes a series of instructions, and executing an instruction involves the following steps. So the ALU computes some operation, then it writes the result to a register or a memory location, and then it deduces which instruction to execute next, which is then fetched. That instruction will be executed, the next instruction will be fetched. So this is just this kind of fetch execute cycle is just done repeatedly. So I want to mention architecture, because there's different, this architecture term can be used in different ways. So you'll see it referred to in terms of the instruction set architecture, or ISA. So this describes the instructions that the computer can execute, and this is a view that's most important to a computer programmer. So when you're a computer programmer, you don't really care too much about how the computer is built in terms of hardware. You just, you're more interested in what instructions a computer can execute. And the term microarchitecture, this refers to the way in which instruction set architecture is actually implemented in hardware. So this is obviously very important to the person who's actually designing the computer. So for a simple example, we know that an add instruction is implemented using a binary adder. So, when you're a programmer, you don't really care how that's implemented. You just want to know, right, I want to add two numbers together. You don't really care how that's done. But if you're designing the computer, you obviously need to know exactly how the add instruction is going to be implemented. And then you also see this term computer architecture used in a more general way, to say the computer architecture. This describes in the complete system, and it shows how the processor, the memory, the buses, and all the peripherals are kind of connected together. So these are the different different kind of terms that contain the word architecture, so just be familiar with those. So the hack architecture, at this point we've basically built the entire hack chipset. So we've got all the, the logic gates and the multiplexers and demultiplexers. We've also built the half adder, full adder, adders, incrementers, and the actual ALU. And then we've built the memory parts. So we've built the flip-flops, bits, registers, and combine those together to build the RAM block and then the program counter. So this bit, we've got the entire chipset, and then this final part now is where we're kind of putting these pieces together to actually build, the final hack computer. So you actually need to build the memory, the CPU, and the computer itself. So the specification of the hack computer, so it's a 16-bit machine. It's got physically separate instruction and data memory. So it's got 32K of instruction memory, so what we call ROM. So the read-only memory, this stores instructions that will be executed. And it's also got 16K of data memory, or the RAM. So the screen, it's got a black and white screen. So 512 times 256 pixel black and white screen. It's got a standard keyboard, and this executes programs written in the hack machine language.